This is part 1 of 3.3. We'll be discussing the increasing and decreasing functions. So we're looking at basically where a function is going up and where a function is going down. And before we begin, we discuss mathematical interval notation. Now you might have used this in pre-calc and possibly even in algebra 2. An open interval is going to be parentheses that don't include the endpoints. So if it's inequality, it'd be a is less than x, but x is less than b. So it's everything in between, but not including the endpoints. And a fancier mathematical notation would be x, and this little e-looking symbol means that it's an element of. That means it's going to be anything that's in between a and b. So sort of like if this is a number 3 and this is 7, x is an element of, x is anything between 3 and 7, but not including 3 and not including 7. Closed interval is going to include the endpoints, and that's when you put brackets around, and that's going to be a is less than or equal to x, but it's also less than, x is less than or equal to b. So you could equal the endpoints as well as everything in between, and then that's written as x is an element of the closed interval a to b. Alright, now that's as far as the notation. Now as far as the definition of an increasing and decreasing function, I'll let you pause this for a second and I'll explain. The first one is that if the derivative is positive, that means that the function is going to be increasing. So positive derivative means that you have positive slope. So if your slope is positive, then your function is going to be increasing. Second one says that if the derivative is negative, it's less than 0, the function is going to decrease. So if you have a negative derivative, that means you have a negative slope. So negative slope means you're decreasing. The first example, Deal looks at it graphically. And I'll give you a moment to pause this, copy these graphs the best that you can into your notes. The first one, we're looking at intervals where it's increasing, so where this has a positive tangent slope. So basically when this graph of this function is going up, looks like it's increasing from, we're going to assume this starts at negative infinity, so it's going to increase from negative infinity and right up until about negative 2. And then it also begins to increase from 1 till 3. So it's going to go from 1 and then till 3. So x could be any number between negative infinity and negative 2 for increasing. And then x could also be anything in between 1 and 3 for it increasing. For decreasing, I'm going to switch over to the fancier mathematical notation with the element. Decreasing, it's going to be from negative 1 to positive 1. So we're going to say x is an element of negative 1 to positive 1. And then it also looks like it's decreasing from 3 till infinity. So from 3, infinity. That's where all these have a tangent slope, which is decreasing for those. For g of x, for it to increase, I'm going to switch to the fancy mathematical notation. X is an element of. Increasing means that it's going up, so it's going up from negative 2 until positive 2. And also increasing, going up from 3 to infinity. Decreasing is where this is going down. I'm going to go back to the inequalities, so it looks like it's going from negative infinity to negative 2. And then it decreases briefly from 2 to 3. Let me put a comma up here. So those are the intervals where it's decreasing for g of x. Now let's look at an actual example without the use of a graph. So find intervals at which h of x is increasing or decreasing. Well, based on the definition, I need to discuss where the derivative is either positive or negative. So the first thing I have to do is find my derivative. So I'm going to find h prime. This is all going to be straight power rule for each one of these terms. First one's going to be 6x to the second minus 6x to the first power, and the derivative of negative 12x is just negative 12. Alright. Now going back to how I find out where it's positive or negative. When I was looking at where this was positive, when this was increasing and then decreasing, where there's a switch from increasing to decreasing, I briefly have a horizontal tangent, which means the derivative is equal to 0. Sort of like a critical point. Same thing as if I have a switch from decrease to increase. There's a 0 derivative, which is a critical point. Up here there is also a 0 derivative. And down over here there was a kink, which would be the derivative is undefined. And up here there's also a kink, so the derivative is undefined. So again, I'm looking for critical points where it would be switching. At 3, it had a critical point, which also meant the derivative switched from decreasing to increasing. So what I have to do is find the critical points to this. So I have to set this derivative equal to 0 to start looking for whether it's going to be positive or negative. So I can factor out a common term. This is going to be minus 2. I can factor this further. It's going to be x minus 2, x plus 1. Solving this, I only have to worry about solving the parentheses. So it's going to be x minus 2 is equal to 0, x plus 1 is equal to 0. So it's going to be positive 2 and negative 1. So these are the points where it's going to have a possible switch from increase to decrease, because that's where it's going to have a horizontal tangent. Again, if I have a switch from increase to decrease, my derivative is 0 at the maximum, and if I have a switch from decrease to increase, the derivative is 0 at the minimum down over here. So now I have to do the sign analysis to figure out where it's positive and negative. So h prime sign analysis. Alright, so what I do, kind of like we were doing for the motion problems, figuring out when the velocity was positive and negative, I got to figure out where my derivative is positive and negative. So if I put these on a number line, it's going to go negative 1 and positive 2. Now what I want to do is plug in values that's in between these intervals into my derivative. So I'm going to pick h prime and plug in negative 2. In between now negative 1 and 2, I can plug in h prime of 0 and h prime of, let's say, 3. And to make things easier, I'm going to plug these numbers not into this derivative, but into the factored derivative, because I can easily plug this in and just figure out if it's going to be positive or negative. So if I plug in negative 2 into here, this gives me a negative derivative, negative parenthesis. This is also negative. So two negatives multiply out to be positive. I can plug in my 0 into the factored derivative, which is going to be negative times the positive value, which is negative. And then if I plug in a 3, it's going to be positive here, positive there. So it's positive. My derivative is. So then I can then summarize using the definition of where my derivative is positive or my derivative is negative for these two. So I can say h of x is increasing, and I can put interval notation x as an element of. The derivative was positive from negative infinity to negative 1, and also from 2 to infinity. And you would say h of x is decreasing. From x as an element of only from negative 1 to positive 2. And what you can do next is copy this graph I'm going to put up into your notes, because this is going to be the graph of h of x, which is in black, as well as the graph of h prime, which is the dotted blue one. And what we did by hand was figure out that it's increasing from negative infinity to negative 1. So you can see that this is going up from negative infinity right up until negative 1. And you can also see that the derivative is above the x-axis, it's positive over that same interval. Then it begins to decrease from negative 1 to 2. So this black function, the h of x, is going down on that same interval. And the blue dotted derivative is underneath the x-axis, so it's negative. And then it's increasing from, again, 2 to infinity. So this is h of x, it's going up from 2 to infinity, and that corresponds to the derivative being positive from 2 to the infinity. Alright, so this matches up with what we did by hand. And the last thing is, I want you guys to try to solve this on your own. See if you guys can find the intervals on which this is increasing. So I'll give you a moment to pause it, and then in a moment I'll show the answer. But I want you guys to try to solve this on your own. And then in class tomorrow, when I'm checking your notes, I'm going to see that you at least attempted the problem. And if you got the wrong answer, then we'll kind of discuss and go over the answer together. But I want you to at least have tried this on your own before I check your notes tomorrow. So you should have had enough time now to at least try it, and I'm going to flash up the answer. So you should have got it increasing from negative infinity to 0, and then from 2 to infinity. And I'll be checking that you have at least attempted this in class tomorrow. And that's it for these notes.